Hello, Algebra students. We are in section 9-3, day 2 today, and we are talking about quadratic equations still, but now we're going to learn a new way to solve them. We're going to solve them by using square roots. So today, that's what I'd like for you to be able to do, to solve a quadratic equation by using square roots. So far, we've only talked about solving quadratic equations by graphing, when we plot the parabola and look at where it crosses the x-axis. But there's more than one way to solve a quadratic equation. This is a method using square roots, but there's a certain term that must be met, or a certain condition. Before finding the solution to a quadratic equation using square roots, you must have this condition. There can be no x term in the middle. That's important. So all of our equations thus far have been y equals ax squared plus bx plus c. In other words, you must have the b equal to 0. So in other words, b must be 0. So we want it to look like y equals ax squared plus c. So you could have 0x in the middle, but that's just redundant. But if you need to put plus 0x in the middle, you can. When we have it in this form, we're able to solve using the strategy I'm about to show you. So the first thing you're going to do is get the ax squared all alone, and then get the x squared all alone, and then square root both sides. So let's just jump into the example so you can see what I mean by that. In example 1, we're going to do the first 4. It says solve quadratic equations by square roots. Here's what you do. Step 1, get the x's or get the x isolated. So I'm going to add 75 to both sides first. Now I have 3x squared is equal to 75. I now need to get rid of this 3, so I'm going to divide by 3 on both sides. And I have x squared is equal to 25. I have to do the inverse, or the opposite, of squaring a number. The opposite of squaring a number is square rooting it. So I'm going to square root both sides. Now here's what the interesting part is. A lot of people would say, oh, the square root of 25 is 5. And you're correct. But there's two numbers that can be the solution here. X equals 5 and x equals -5. Because remember, if I take -5 times -5, well, that still gets me positive 25. So both of those numbers will work. All right, let's do that again. First, we're going to get the x all alone. So I'm going to add 1 to both sides. That gives me 3x squared is equal to 3. Then I'm dividing by 3 on both sides, and that is x squared is equal to 1. I don't want x squared, I only want x. So the inverse of x squared, or the opposite of x squared, is the square root of both sides. Now, x could equal positive 1 because 1 times 1 is 1, or it could equal -1 because -1 times -1 is 1. What we're doing here is quickly finding where the parabola crosses the x-axis. So what these actually mean, this is where the parabola crosses the x-axis. We're finding the roots. We're finding the solution. Let's do that for example C. I'm going to subtract 15 from both sides. And now I have 3x squared is equal to -15. I'm going to divide both sides by 3. Now I have x squared is equal to -5. When I square root this, something unique is happening here. I have a negative inside of a square root symbol. And here's the thing. For two numbers to multiply to a negative, one must be positive and one must be negative. It is impossible to have the same number multiply with itself to get a negative. So that means this one has no solutions. No real solutions. I can put it like that. Let's do example D real fast. Example D, first you're getting your x's alone, so I'm going to subtract 16 from both sides. So I have 4x squared is equal to 0. Now I'm dividing by 4 on both sides, getting me x squared equals 0. Square root both sides, and this time there's no such thing as a positive and a negative 0, so I'm just going to say x is equal to 0, and that's my solution. I'm going to save 36, E and F for class time later on. Let's flip our page over, and we have the same type of concept, but it could be written slightly different. You might have a binomial squared, and remember, a binomial just has 2 terms in it. So if you're faced with a problem with a binomial squared, then follow these steps. You're still going to take the square root of both sides, and you're still going to have a plus or minus option. But then you're going to have 2 separate equations you have to solve, where one of the variables or one of the answers was positive and one of the answers was negative, and then you solve for both to get your 2 answers. Let's do that here. I have the binomial on one side and a number on the other. I'm going to square root both sides right off the bat. So this just becomes x minus 7 is equal to, but the square root of 16 could be positive 4, but it could also be negative 4. So it could be positive 4 or negative 4. So what we want to do is rewrite that 2 times so we can see the 2 equations. I've got x minus 7 equals 4, x minus 7 equals negative 4. Now let's solve for x in both equations. So x could equal 11 and x equals 3. There are my solutions. Let's do it again for example B. I'm square rooting both sides. So that gets me x plus 2 is equal to plus or negative 2. The reason it's plus or negative is because 2 times 2 equals 4, but also negative 2 times negative 2 equals 4. So we want to solve both of our equations. X plus 2 equals 2, x plus 2 equals negative 2. When I subtract 2 from both sides, I get x equals 0 and x equals negative 4. So those are my 2 solutions. I'm going to save both of these for class time as well. So that's all for tonight's video. I hope you have a wonderful night.